Okay, math teamers, here's a video for complex numbers. It's one of the categories in MEAT number 3. You can't take a square root of a negative number. So somebody came up with imaginary numbers. It's true. And I represents imaginary unit, and I equals the square root of negative 1. So if you square I, you get negative 1. Okay? Complex numbers, they have a real and an imaginary part, often written as, and your answer often has to be written as the real part plus or minus the imaginary part. Some particular things. You can't have an imaginary part in the denominator. It's not proper form. So to get rid of it, we multiply by the complex conjugate. Instead of 2 plus 3i, we multiply by 2. Instead of 2 minus 3i, we multiply the numerator and the denominator by 2 plus 3i. And what eventually happens because of that, is that the denominator will become an integer, because you have the difference of squares here, so it becomes 4 minus 9i squared. I squared is negative 1, so you end up with changing it to a plus. 4 plus 9 is 13. So this is the proper way to write this fraction. Okay? And we might use synthetic division to solve some polynomials. Let's jump right to some problems. Oh, no, another example. Let's say you know that 2 plus I is a root of a polynomial. Well, if you know 2 plus I is a root, you also know 2 minus I is a root. And there's a shortcut way to figure out how to get the other roots. But let's pretend this is the polynomial, and we only know that 2 plus I is a root. Well, we can do synthetic division and carry that out. Notice it came out to 0. And these would be the values of A, B, and C using the quadratic formula, which could be tough because we're not used to having imaginary numbers in A, B, and C for the quadratic formula. So here's a different strategy that you could use. I mean, you could use it, just take some time. Another strategy is, if you ever have an imaginary root, a complex number root, use the sum and the product rule. The sum of 2 plus I and 2 minus I is 4, and the product of 2 plus I times 2 minus I is positive 5. Thus, a factor of the original polynomial, you would write x squared minus the sum having trouble writing, minus the sum and plus the product. So since you know that is these two roots, what we could have done is did long division. If you do long division, you find out x minus 1 is another one of the roots, or another one of the factors, which means positive 1 is one of the roots. I don't think these problems have anything to do with those, but that's some background for people who are going to do some higher end problems. Let's try this. Find the value of the expression t minus b given that t plus bi equals this. Okay, so we're going to just multiply binomial times a binomial. 8 times 4 is 32. 8 times negative 3i is negative 24i. Positive 2 times 4 is positive 8i. And the last one, the 2i times the negative 3i, bear with me, 2 times negative 3 is negative 6. But then you have I times I, which is I squared. So you have negative 6I squared, but I squared is negative 1. So we really have plus 6. Okay, now combine like terms. I have a 32 and a 6, so that makes 38 for the real part. And then I have a negative, what is that, negative 16i? Negative 16i. Oh, they wanted us to find t minus b, with t being the real part. So instead of writing minus 16i, I guess I will, minus 16i, but they want me to go t plus b. No, they want me to go t minus b. So let me get rid of the I. And if I want to go t minus negative 16, that means I'm adding. That means the answer is 54. Let me check with my answer sheet. Yes, 54 is the correct answer. Hopefully you followed all that. All right, let's try this one. We got some i's, I squared, I cubed, I to the fourth, I to the fifth. Okay, I'm going to go one thing at a time. I got my I. 3i squared. Well, I know I squared is negative 1, so that's really minus 3. Minus 2i cubed. Well, in the I cubed, I have an I squared. So I can take the I squared out as negative 1 and make it a plus 2i. I to the fourth is my favorite, because that means you have negative 1. You have I squared times I squared, and I squared is negative 1. So negative 1 times negative 1 is 1. So this just cancels out with the whole thing, and I'm left with plus 4. And likewise, I can do that with the 5. The 5, I can take out an I to the fourth, because that's just 1, and I'm left with 1i. So minus 6i. All right, minus 6i. That's in the numerator. Let me simplify it. I have I plus 2i is 3i. 3i minus 6 is negative 3i. And for real parts, I have negative 3 plus 4, which is a positive 1. Now that's divided by 2i plus 1, and that is not a proper denominator. I need to multiply by the complex conjugate. Pretty sneaky the way they wrote it. They wrote the imaginary part first. I have to go the opposite of the imaginary part, so it's negative 2i plus 1. And times negative 2i plus 1. All right, this could take a bit of time. Maybe I can shortcut it, if you don't mind. Negative 3i times negative 2i would be positive 6i squared, but I squared is negative 1, so it's negative 6. Negative 3 times 1 is negative 3i, but then I have 1 times negative 2 for negative 2i, so I have negative 3i minus 2i is minus 5i. Having problems writing. And what else? What did I forget? The 1 times a 1 is 1. So if I want, I can let me change this to a negative 5, because negative 6 plus 1 is negative 5. There's my numerator. Let's see if I can make that better I out of that. In the denominator, this should come out to an integer. Let's see what the integer would be. It's the difference of squares. So I have 2i times negative 2i is negative 4i squared, which is positive 4. And then I have 1 times 1, which is 1 times 1 is 1. So I have 5. Oh, they're all divisible by 5. So let me divide them all by 5 and get negative 1 minus 1i. This problem had a lot of parts to it, because now I need to take the magnitude of it. And the magnitude is when you, it's kind of like Pythagorean theorem. We have a negative 1. We have a negative 1 in the real direction, and we have a negative I in the imaginary direction. So what's this magnitude? So it's like a 1 and a 1. 1 squared plus 1 squared equals the hypotenuse squared, and we're going to take the square root of that. So 1 squared plus 1 squared is 2. So it comes out to the square root of 2. That's how you do magnitude. All right, let's try some more. This is similar to, I like I like these 3-point problems. Looks like we just need to multiply. 6 times r is 6r. 6 times 2i is 12i. Negative 4 times r is negative 4ri. Now this isn't that easy. It's got that r in there. They want us to figure out what r has to be. And then negative 4i times 2i is negative 8i squared, but then the I squared is going to make it a plus 8. All right, I need to get 17 for the real part. These are the imaginary parts. So the real parts is 6r plus 8. 6r plus 8 has to equal 17. So if I subtract 8 from both sides, I'll get 6r equals 9. Divide by 6 and I'll get 3 over 2, or 1.5. 1.5. Let's see. Let me look at my answer key. Yeah, 1.5. 1.5 or 3 over 2. Now, that was weird. We didn't even have to use the imaginary part, but if we did, I would write 12 minus 4r equals 6. And if you solve that for r, it also comes out to 3 over 2. All right, let's try out this 4-point question. If a and b are integers, and 3 plus ai times b plus 5i equals 32 minus I, holy smokes, find a minus b. All right, let's multiply this out. 3b plus 15i and then I have this, which is abi, I guess, plus abi. And then the ai times the 5i is a plus, let me change that. It's a plus 5ai squared, but I squared is -1, so I'm going to make it a minus 5a. Because it was plus 5ai squared, and the I squared is -1, so that this equals 32 minus I. All right, so this is the real part, 32. Where's the rest? This is the real part. This is real. And this is real. 3b minus 5a equals 32. Can't solve anything there yet. Let's see about the imaginary part. 15 plus ab equals -1. 15 plus a times b equals -1. I didn't write the i's because they were all it's the imaginary coefficients have to add up to each other. I mean, have to make the equation true. Wow, this is a weird equation. Subtract 15 from both sides and get a times b equals -16. And if I divide by a or b, I can solve it for a or b and then substitute it in over here. What a mess that'll be. Let's see. I did this problem earlier. Let me see which way I did it. And I think I substituted it in for a. So let's divide b by both sides and get -16 over b. And that's what a is. So now this equation becomes 3b minus 5 times -16, which is 80. But it's negative times negative, so I can make this a positive 80 over b. I just substituted in for a. I took the -16 over b and plugged it in for a. That equals 32. Still a mess. Let's subtract 3b from both sides, and that will give me 80 over b equals, I think I'm going to stop soon so the video isn't too long, 32, what was it, 32 minus 3b. And then what I did is I put this over 1, and then I solved it like a proportion. 80 equals 32b minus 3b times b, so there ended up being a b squared, and I ended up using the quadratic. But way up here they said a and b are integers, and only one of the values of b is an integer, and click pause if you want to finish it. The answer was B was 4. Oh, they want us to find A minus B. B was 4. And what did I get A was? After I got B was 4, oh, then you can plug it in here and get that A is negative 4. And then they want A minus B, so it's negative 4 minus 4. Final answer, negative 8. Wow, that one took a lot. Let's see if I have any more to try. Nope, that's for another category. That's it for this video. Have a great day.